In section 12.1, we will look at tangent lines. Tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So in our example on the right, that would be line AB. Point of tangency is the point where a circle and tangent intersect. So that would be point B in our diagram on the right. Theorem 12.1 says if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So there's a key word there that's perpendicular, which means we have a right angle formed between the radius and that tangent line. In our first examples, we want to find the value of x. In number 1, line segments LM and NM are tangent to circle O. So that means at L we have a right angle and at N we have a right angle. Now we have a quadrilateral in number 1, so that means our interior angles will add up to 360. So we can say 117 plus 90 plus 90 plus x will equal 360. Then if we want to solve for x, we just subtract those numbers from 360 and we get that x is 63 degrees. Similar number 2, we're told line segment DE is tangent to circle O. So that means we have a right angle at D. Now the interior angles of a triangle add up to 180. So we can say 90 plus 38 plus x equals 180. And then subtracting our known angles from 180, we get that x equals 52 degrees. And finally, number 3, line segment AB is tangent to circle C. So that means we have a right angle at angle A. So again, our interior angles will add up to 180. So 90 plus 22 plus x equals 180. Subtract our two angles from 180, we get that x equals 68 degrees. In number 4, it says a dirt bike chain fits tightly around 2 gears. The chain and gears form a figure like the one at the right. Find the distance between the centers of the gears. So we're looking for this distance here. We're just going to call that x. So if you notice in the figure they gave us the radius is 9.3 in the larger gear. They were also given this rectangle. So this side, this little part's 2.4. This will also be 26.5. Here is my right angle. So then this distance is 6.9. Let's fix that 6. If you take 9.3 minus 2.4, you get 6.9. Okay, so I want to solve for x. Well, if I know 2 of my 3 sides in a right triangle, we'll use the Pythagorean theorem to find x. So that 26.5 squared, oops, I'm going to plus there, plus 6.9 squared equals x squared. Now if I square these and add that together, that's 749.86. That equals x squared. And then I'm going to take the square root of both sides, and rounding to the nearest tenth, I get 27.4 inches. So that equals x. So the distance between the two centers of the gears is about 27.4 inches. Number 5 says a belt fits tightly around two circular pulleys, as shown at the right. Find the distance between the centers of the pulleys. Okay, so I'm going to draw in our length that we're looking for. So we have a right triangle formed. Here's my right angle. They gave us a rectangle, so I know this side's 8. This side is also 35. If I take 14 minus 8 to get 6, that would be this length right here. And we're looking for the distance between the two centers of the pulleys. So I'm going to call that x. Okay, so again, we know 2 of the 3 sides in a right triangle. We'll use Pythagorean theorem. So 35 squared plus 6 squared equals x squared. 1225 plus 36 equals x squared, or 1261. Then taking the square root and rounding to the nearest tenth, we get the distance between the two pulleys, about 35.5 inches. Number 6 says a belt fits tightly around two circular pulleys as shown below. Find the distance between the centers of the pulleys. Alright, so we're told in our pulley on the right, our radius is 7, so that means this radius is also 7 centimeters. We're looking for the distance from one center to the other. So you'll notice we have a rectangle here in this bottom figure. So that means this length is 15. We are looking for the distance from one center to the other. In our rectangle, our sides are 3. Then if it has to add up to 7, that means this distance right here is 4. And here is my right angle. So again, knowing 2 of the 3 sides, we can use Pythagorean theorem to solve for our missing side. So 4 squared plus 15 squared equals x squared. 16 plus 225 equals x squared. So 241 equals x squared. And taking the square root and rounding to the nearest tenth, the distance between the two centers of the pulleys is about 15.5 centimeters. Theorem 12.2 says if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So in number 7, we want to know if line segment ML is tangent to circle N at L, and explain. So the question is, do we have a right triangle? Is there a right angle at angle L? So to find out if triangle MNL is a right triangle, we'll use the Pythagorean theorem. Does 7 squared plus 24 squared equal 25 squared? So does 49 plus 576 equals 625? And yes, 625 does equal 625. So the answer is yes. Line segment ML is tangent to circle N. Same idea, number 8. Is line segment AB tangent to circle P at point B? So again, we use Pythagorean theorem where angle B would be the right angle. So does 5 squared plus 12 squared equal 13 squared? Does 25 plus 144 equal 169? Yep, it does. So the answer is yes, that line segment AB is tangent to circle P at point B. Inscribed in is a circle drawn inside a polygon with the sides of the polygon tangent to the circle. Circumscribed about is when a polygon is drawn outside the circle with its sides tangent to the circle. In Theorem 12.3, the two segments tangent to a circle from a point outside the circle are congruent. So that means side AB is congruent to side BC, that their lengths would be equal. Number 9 says line segments QS and QT are tangent to circle O at points S and T respectively. Give a convincing argument that the diagonals of quadrilateral QSOT are perpendicular. Okay, well, if QS and QT are tangent, that means that they are congruent. So we know that side QS is congruent to side QT. We also know that we have right angles at angle S and angle T because the lines are tangent at those points on the circle. And we also know that SO is congruent to TO because they are both radii in the circle. So the question is, are the diagonals perpendicular? Well, going by the markings on my figure, I know that this figure, it's either a kite or a rhombus. And both those figures, the diagonals are perpendicular. So we could say it's a kite or a rhombus, so the diagonals are perpendicular. Okay, and our last example in this section. Number 10 says circle C is inscribed in quadrilateral XYZW. Find the perimeter of XYZW. Okay, so if the circle is inscribed, then that means that our lines are tangent to the circle and they are congruent. So if XR is 11, XU is 11. If TW is 7, UW is 7. If ZT is 6, SZ is 6. And if YR is 8, then YS is 8. Now to find the perimeter, we're just going to add all the sides up. So we have 2 8s plus 2 6s plus 2 7s plus 2 11s. So adding all those up, we find our perimeter is 64 feet.